Okay. I guess it's time to start now. Bonjour, bonsoir. Je suis Carlos. I'm gonna do this in English better, if that way it's gonna be worse for you because you won't have a laugh of my French accent, but it's gonna be better for me later on for my personal humiliation, let's say. So that's my Twitter handle, Sanchez, if you want to tweet anything about the session and say anything or ask me any questions later or during. And my background, I'll just explain a little bit. It's a lot with development tooling, Apache Maven, mostly a member there for over 10 years now. So I come into this world of more like runtime and containers and operations and DevOps in the last 5 years or so. So evolving from the development side all the way towards the other dark side of there. And I've been contributing to Maven, into the Apache Foundation, into the Eclipse Foundation, different projects here and there, and recently Puppet modules in Java, Ruby, all sorts of different things. And I just recently have started working for CloudBees as of last week. So expect a lot more of the stuff that you're going to see today happening there on the Jenkins world too. So with that, I'm going to start talking a little bit about containers and microservices before. So I would like to get an idea of how many people here have not heard about Docker. Good, because if you haven't heard about Docker, then this is not your talk, probably. How many people is using Docker to some extent? So pretty much everybody. How many people is using Docker seriously for something serious? Not production, but something serious. Okay. Is there anybody using Docker in production? Jesus, this is like three people here, 4. This is crazy. This is going up from 1 probably a few months ago, and this was like a DevOps meetup where you were supposed to have a lot more people happening, and there was only 1 person running Docker in production. So containers are coming from a world where you need things to scale. This is one of the main motivators of people, or all the new trends, or all the cool buzzwords happening now in the container world. And that's obviously, that goes up with when Google comes out and says there are starting like 20 billion containers per week. I imagine this is American billion, so 1,000 millions. And so they have been using containers for, I don't know, over 5 years for sure, probably I think a little more than that. And that's one of the main use cases for containers, like running highly distributed applications. But with that, there's also some other issues that come from the world of containers. I mean, you gotta know how to use them. It's not just trivial to use containers because it causes to switch your paradigm on how you understand things. Sometimes you may find some problems that you didn't have before. So it's a new solution for problems that also brings new and very interesting problems. And don't expect your manual processes to work with containers. They're pretty, I mean, once you start, it's not just a containers problem, but a scale problem. Once you start doing manual stuff, then maybe containers is not something for you. So this is a world for like, or the last trend is moving towards a microservice architecture, service-oriented, as you probably heard from many years ago. But there's still a lot of people that don't work that way. There's a lot of people thinking about virtual machines or bare metal machines. And this is a world for service-oriented architecture and having services, not caring about the individual machines. So there's always the discussion about containers as lightweight virtual machines. So from the pure perspective point, they are not lightweight virtual machines, but they kind of solve the same problem sometimes. So how many of you have used Vagrant? Okay, so how many of you switched to Docker for stuff that they were doing with Vagrant? Well, for those that you didn't that, you probably have to think about it if you want. I have switched from, Vagrant provides you the way to have virtual machines really easily, provision them and use them and throw them away. Docker, using Docker as a lightweight VM, it's another solution that is faster and will work for most of the use cases. So on the container world, instead of having all these layers on top of the host OS, like the guest OS and the hypervisor, and then your app running on top, then everything gets trimmed a little bit shorter. So you have the containers running on top of the Docker server on the host OS. But you gotta keep in mind that containers are actually processes. Although you could use them as lightweight VMs, they are actually processes running on a server. So Docker, it's the cool thing after the best thing after sliced bread, and it's not something. The technologies are not new. So you have Linux containers that have been around for a long time. The new thing about Docker is how it uses the technologies and how it makes the life for our life to use those technologies. So it combines the Linux containers that existed for a long time and bringing isolation at the file system level, at the processes, users, network levels. So you have isolated processes running on your Linux servers. And on top of that, you have the union file system, which is the different layers that you can use to build your Docker images. So it's basically something like Git, or in the sense that you can have things on top of other things. So it's a version file system and a union, so you can have different layers coming from different places. So obviously Docker requires Linux, because it only runs on Linux, but you can use boot2docker to run on OS X or Windows or some of the other OSs. And you can build your containers once or your images, run them anywhere, as long as it's Linux. But you can run them in bare metal machines, virtual machines, on the cloud, and you can also run Docker inside Docker. So there's specific device mappers in Docker allow you to run Docker inside Docker, which I haven't tried yet, but it's an interesting use case for the examples I'll show later. So you could run Docker as in your development environment or your continuous integration environment. So this is a hilarious tweet that I read. The solution is Docker now for everything. Now, just whatever problem it is, the solution is Docker. So, one of the good things of Docker is that it helps both developers and operations people. For developers, it avoids dependency hell, installation nightmares, and the works on my machine. But it's very appealing for operations people because they don't have to know all the internals of your application. So you can just give them a Docker container, and they can just run it, and they don't care about what it does too much. And they can focus on other stuff that is more important for them, maybe. or more important for the business, if you want. So how do you deliver a Docker image or a Docker container? You have the system. So basically, you can have Docker images like based on Debian or CentOS or RedHat or whatever it is. And then you have your app, and you bundle both things into a Docker image that then runs in whatever Docker infrastructure. So it helps to be composable that way. So you can mix and match a lot of different combinations of apps, systems, and so. And you have a lot of official repositories for anything Docker-based. There's like pretty much anything you may imagine, and there's more and more images going into the repository. For instance, one of the official images that I made was the Maven, Apache Maven image. So you can use Docker images with different versions of Maven in different JDK versions. So you could just get, if you want to try something on Maven 3.3 on the JDK 8, there's an image ready for that you just have to download and run. So I see it's a huge potential for development. I mean, it's going to come to production, but right now, today, for development, it's just a lot of potential. And on the Docker registry, you have a list of contributors, popular repositories, because the good thing is that anything can end into the Docker registry. The bad thing is like you have no idea how good an image is going to be. So there's some features there to start repositories and see how many people download an image and so. And this is the Maven image that I've created. It's one of the official build images. Docker has this concept for things that they build themselves. I mean, you can provide an official image for anything. You just say, this is the Docker file that builds the image, and they will take care of building and publishing that. So as you can see there, maybe there's combinations of JDKs, 7, 8, 6, and there's in the tag section you would see all the several versions of Maven, the latest ones. And for the use case that I'm going to talk about later with Kubernetes, it's the continuous integration, continuous delivery use case. So you could have your sources and whatever application that you're building, and then create not only your application, but also create a Docker image that you push to a repository. That could be a public repository or a private repository. You could move that from repositories the same way as Maven would do for Maven repositories. So you could have, this is the idea, that you could have staging repository for Docker images, maybe a production repository, so you could promote images from one to another. And so you're building your app, you're building the image, the container that runs your app. Then you push that to a repository. Then from that repository, all the machines that you are running in different environments can pull information, can pull the images, and then you run that, whether it's some physical, virtual, cloud, or any combination. So it's a pretty good view of how, with Docker, you can optimize this cycle of development and continuous iteration and continuous delivery. Well, for those, everybody knows Docker, so I'm just, how to run it. And I thought it would be worth mentioning alternatives. Anyone has heard about Rocket? Use Rocket? Okay. Yeah. So Rocket is an alternative to Docker, done by the CoreOS guys initially. It defines 3 parts to what a container is. So a definition of what an image is, of what the runtime, and how to discover containers. So the CoreOS guys basically came back and said Docker is becoming too big. and we just want a container. And they came up with a new specification that anybody could implement. And that's probably the two main parts of that is the specification of what an image is. So basically it's a tarball and has to have these things here and these things there. And the runtime, the interesting part of it, it's that it's not using a daemon like Docker is. So it's just executable. So in case you wonder, I thought it would be worth mentioning. And the other interesting thing is container optimized operating systems that, who has heard about CoreOS? Pretty much everybody. So CoreOS, I would say, is the most popular one of this new trend of operating systems where you have a minimal OS that is optimized to running containers and run only containers. And there's no package manager, everything runs on a container, and you have atomic updates of the OS. So how CoreOS does this, I'm not sure about the other ones, but it's similar concepts. CoreOS has two partitions, one with the OS that is running, and when you get an update, it gets pushed to you. It gets into another partition, and then it swaps one to another, and it's really easy to do rollbacks and upgrades across multiple hosts. So something worth looking into at some point. And so Kubernetes, it's a new project created by Google, I think probably less than a year ago. So the idea being, how do I run Docker containers at scale? So you have, right now, you have multiple Docker hosts that are running containers. But once you have one Docker host, and then you move to another two Docker hosts, and so on, it becomes a nightmare to manage. Where do I have my containers? Where should I put the containers? How much load does it need? And what happens when a host goes down? And so on. So those are the types of goals that Kubernetes is trying to solve. And I love this quote from Kelsey Hightower, one of the CoreOS guys. How would you design your infrastructure if you couldn't log in ever into your machines? So this is the idea, one of the ideas behind Kubernetes and some of the new stuff that is coming out, like CoreOS and so. So how would you run things? How would you use APIs? And how would you use management and logging and monitoring so you don't have to log into your machines ever? And how you can recover from failure and so on automatically. So Kubernetes is defined as a cluster orchestration, whatever that means. Well, it means different things for different people. So the idea being you can have multiple Docker hosts, and you're going to have a way to interact with all of them as a single entity. These hosts are called nodes, or were called previously minions. And Kubernetes provides a higher level API than Docker to do tasks on creating, destroying, and so on the containers. So I jumped ahead. Who is using Kubernetes today or has used it to some extent? There's one guy. Okay, who has heard about Kubernetes? Okay. So the other point is enforce the state. Kubernetes doesn't, you don't tell Kubernetes, I want to start this container here or there. You just say, I want X number of containers running. I don't care where they are. Or maybe you care, but you specify exactly declaratively. So it's not imperative, it's declarative. You say, I want this number of containers running, and maybe you specify some constraints on how much CPU do you need, how much memory, but you don't say, run this container here or there, which is something that previous tools with Docker were doing. And it also provides monitoring. That's the part that I mentioned, that it's like a lot higher level than than Docker. On the master, you have several services running. You have the API server, so you basically interact with the master all the time. And you have the API, and it has the scheduling and synchronization capabilities. So when you say, Kubernetes, I want this container running, you talk to the master, and he's going to do stuff behind the scenes to get that done. And how does that work is using etcd. So there's a cluster of etcd servers running, and that's where the Kubernetes stores all the information. Kubernetes uses a lot of existing tools, so that's a good thing because you may be familiar with some of them. So it's a lot of moving pieces, but a lot of well-known moving pieces. And the other thing is the Kubernetes controller, that it implements the replication, and basically it's implemented by watching etcd. So whenever a change is done in the configuration, it will trigger the changes necessary for that to happen. On the nodes, you have Docker, obviously, running, the Docker server. You have Kubernetes, which is, it's running as, so all this is running as containers. That's one of the interesting part of that. I'll show you later in the demo that everything that is running on the nodes is running as Docker containers. So you have the Kubernetes service that ensures the state of the pod, so it watches Docker and knows what containers are running. Simple network proxy, and I'll talk about networking later. etcd in some of the nodes too, and Kubernetes is adding more and more services. Depending on what version you are, there's more and more services being added. Like I started with Kubernetes probably 8 months ago or so, and it was a lot less stuff. It's bleeding edge. I can tell you that it's really bleeds. It's you start something today and tomorrow didn't work, or there's a new change. No, God, this doesn't work anymore. And well, this other thing that I did now is not there anymore, and the API has changed a little bit and here and there. So things that are being added, SkyDNS. So you have DNS service running on each of the nodes that will allow the containers to query other services by name. And last time I ran it, which was probably this cluster I created like a week or two ago, and it has also added Elasticsearch and Kibana for logging. So I expect more and more stuff being added to provide a more compelling service than just running containers. So you're probably not going to see much there, but that's the official diagram of Kubernetes. So it's the master running, and then you have two nodes, the one on top, the one at the bottom, and you have services that schedule things with Docker. So you interact with the API endpoint, and that's going to talk with the nodes, and that's going to do all this magic stuff behind the scenes. You can run Kubernetes on multiple platforms, like Google Compute Engine is the, let's say, first citizen, because Google is doing this, and they are ensuring that Google is the best way to run Kubernetes. But you can run it in any sort of, they provide scripts for all this, and support varies depending on the provider. Like Vagrant is not great to run because there's missing stuff there that you cannot do in a just VM. But they provide the other stuff too. Azure is also very active in the community. And how do you create a cluster? Well, with the command line, once you get Kubernetes, you just decide what provider you want to use. Like by default is GCE. You decide how many minions you want, which is the nodes now. And you just run kube up, and it's going to go out and do its magic. And then you have other options. You have Google Container Engine. on Google Cloud. So they have a web UI and the CLI tools where you can just name a cluster, say, do the same things, and tell in what region it is, and it's gonna start the cluster for you. So you can do the same thing on the command line. Basically, all the Google Cloud stuff, where what project do you want to run it, how many numbers on what Google network do you want it to run. And just recently, like this week, I think it was, that CoreOS announced Tectonic, which is another way to run Kubernetes on top of CoreOS, whether it's on premise or in any cloud provider. So, there's stuff changing every day here. So, getting into what a node is, what are the different components. A node, so this is the host that is running. And you can query the API, and it's going to give you this data that I'm putting on the other side on JSON, or you can also use YAML. So it's going to give you what node is capable of, what the node is capable of, and you can also assign labels to nodes, which are going to be useful if you want to do some sort of constraints. So maybe you want some containers to run in some specific nodes for whatever reason. You can use labels, and labels are used across all the resources. They are a very important way of tagging things. Then the most important concept is the pod, which is a group of collocated containers. So you can define the pod, typical web app. You would have a pod with a web server container. You would have a database container, and that would be a pod, right? They always run in the same host, in the same node, and share network. And you can define environment variables and volumes. So environment variables, so you want to customize your container for whatever reason, the same way you do with Docker containers. And the volumes is the important part for storage. So there's right now, or at least last time I looked, let's say that, there was 3 ways of having volumes. So you could have empty volume, which is basically no persistence at all. You can have host-mounted volumes that are not going to work very well if your container gets started in different hosts. And a very interesting thing that I've used, which is provided by Google, it's you can use data disks if you run on Google Compute Engine. So basically how Google works, if you are more familiar with Amazon, like an EBS volume. So if your container runs in this host and it dies, and now it's restarted in a different host, Kubernetes will attach the disk to the other container, and you will keep the same data. So that's an interesting solution to the problem of moving containers across hosts. When you create nodes, pods, your client talks to the master interacts with all the nodes, where the pods run and all the other services like Kubernetes, etcd, or whatever it is, and the pods get created into whatever node as Kubernetes sees fit. And this is the JSON definition, the first part. I don't know if you can see it from the back. The important pieces are, you decide what Docker image you want, in this case, C Sanchez, Jenkins Kubernetes. You decide what ports you want to expose. So you can either expose container ports to specific host ports or just let it be random. In this case, it's exposing the port 8080 and the port 50,000. And it's mounting a new volume into the var/Jenkins home. So I guess I should say that the example I'm going to run with Kubernetes, it's running Jenkins and the slaves of Jenkins in everything in a Kubernetes environment. So you will have dynamic slaves coming up and going as you tell Kubernetes to scale up and down. So I'm exposing this would be for the master Jenkins server. I'm exposing the 8080 port, and I'm exposing the container port. The 50,000 port, which is the port where the slaves talk to. And basically, I'm saying use a persistent disk for the home directory of Jenkins. The replication controller, it's probably another very interesting part, but it's just a way to say, I want this many pods running. So you could say, for the slaves part, I'm going to define a pod, and I'm going to tell Kubernetes, I want X number of these running. So Kubernetes is going to schedule those running. So if you have a pod A and B, it doesn't necessarily scale them and distribute them. It will, depending on the scheduling that it uses, it may just put all of them in the same node or not. That's one of the things that I don't know if it's yet implemented or not, having that constraint. I don't want all these containers to be in the same node for disaster recovery reasons. But it's going to put them, you just say how many you want, and it's going to schedule them. And this is the way you implement DevOps. So you just schedule, you propagate the errors automatically across multiple places. So the definition of a replication controller is pretty much the same as the pod. I'm just saying here what image I want to run, what command I want to run, because I'm overriding the Docker commands. That's not really important. And in the replica selector here, replicas, I'm saying 1 up there at the top. So I can do that to say I want 1, I want 55. Doesn't matter. Kubernetes is going to handle that. And the other part of Kubernetes are services. Because once you have containers running across multiple hosts, you have no idea where the container is, where the service is. So Kubernetes services allows you to discover this, discover where the pods are running, and have a way to access those pods. It provides you an IP for service, and it routes the pods based on labels. So you could say, basically, this service is going to be a front end to all the containers running, I don't know, Tomcat. So you just use the label Tomcat in your pods, use the label Tomcat in your service, and that service is going to go through them, all the containers. And another thing that I mentioned was the Google's compute engine is one of the first citizens. It also allows you to create a load balancer on Google. So I'm going to show you here. I have 2 services running. So one is the Jenkins master service, and another is the slave. So the master one, I want it to be externally accessible. So the port 8080 that I created before, I'm exposing before in the container, I want it to be externally accessible from the port 8888. So I can do the create external load balancer. And that is up to the provider to implement, and Google implements that. So it's going to create a load balancer on Google Compute Engine. So it's going to give me an IP and a load balancer, so I can, if I have multiple containers running, it will go through any of them. I'm short on time, so I'm going to skip networking because it's a long subject. And I'm going to just mention a little bit some of the related projects that you may have heard of, mostly Docker Swarm. Docker Swarm, it also does clustering for Docker containers, and it uses the same API as the Docker servers, Docker servers. And so a lot of people ask, so what's the difference between Swarm and Kubernetes? So, well, Kubernetes has been there before Swarm, so it wasn't anything like that before. But the goal of Swarm is just to scale Docker hosts and do just that, and use the same API. So you can have multiple Docker hosts connected with a Swarm client, and it will interact with them as if you were talking to one Docker host. It doesn't provide you any of the other stuff that I mentioned, at least for now. Maybe next week, I don't know. But it allows you to, Kubernetes, all the stuff that provides you like replication controllers, the storage, all like service discovery, all that stuff is not done in Docker Swarm. And there's talks about implementing Kubernetes using Swarm behind the scenes and things like that, right? But that's still to see. And I'm gonna go to the examples, right? So this is the GitHub page, and where I have the sample code, and I'm gonna run Kubernetes, Jenkins in Kubernetes with slaves, and this it's not, let's say, the best way of doing it, but it's the best way of showing how it's done, Kubernetes, because there's another project that I have created that is a Kubernetes plugin for Jenkins that basically allows you to specify a connection to a Kubernetes cluster, and it will start Docker containers and destroy them using Kubernetes, so across multiple Docker hosts. And it's going to do it as watching the jobs queue. So what I'm going to show now is how to manually do it, how to manually scale up and down the cluster. But the plugin will do that by itself. So, well, that's basically, you say where the Kubernetes URL is, username, password, and so on, and it will connect there and create the pods necessary to run those slaves. But there's no first version. There's not first version of that delivered yet. But once you have that, then you just can let the containers do their jobs and compile and do whatever while you do other more interesting things, hopefully. So I'm going to show you. Okay. So I have a cluster running, and I have. This is the API endpoint. And I can go in and look at the pods that are running on Kubernetes. So I have the Elasticsearch that I mentioned before. I have the Jenkins one that I just created. So the cluster is already running with everything. If I have time, I'll destroy things so you can see that. And some slaves running, the Kibana logging, the DNS, monitoring. So I think I only have 3 things running, but all Kubernetes by itself is running all the other stuff. So if I go into the Jenkins pod, you will see something like I mentioned before. So I set a label called Jenkins, and I have empty volume in this case. I'm running this Jenkins Swarm image that has the Swarm plugin installed in Jenkins, because I'm gonna use Swarm. Well, no, I think I have done a lot of different demos, so I think this one is just I'm using this, but it doesn't have anything special. And then it will give you the current state, so it's running and so and so, and what's the host IP, what's the pod IP, and that. And I can get the minions that are running. So I have 2 nodes running on this Kubernetes cluster, and they are running on Google Compute Engine. And I can get the pods, which is basically the same thing I got with the API, but in a way that is really hard to read. So I have one slave here, I have another slave here, and the Jenkins master. And you can see what images they are running, and the Swarm master, the Swarm slave. And then I can get the replication controllers. And you can see, well, I only created this one. Everything else is done by Kubernetes itself. So this one is basically saying, I created a Jenkins slave replication controller with this image, and I said number of replicas is 2. And I can get the services. And again, there's only 2 services that I have created. One to expose the port 8888. Well, it's exposing in the port 8888 externally. And you can see maybe here on the right that all of them, all the services are running on different 10.0 networks or IP addresses. So you can connect to any of those IPs on these ports, and if they are externally available, you can see the stuff that is running behind. So the other thing I've done, because this is a little bit more complicated, it's not just that. So get the minions, create the pod, and there's Google creates a, because I set up the service to create the external load balancer, Google creates a forwarding rule. So basically it's telling me this public IP address, and this one is public, is going to this pool that Kubernetes created itself. So it's handling all of that behind the scenes for me. It's creating the external load balancer, and it's creating the connection to the specific nodes that need to. The only thing that I have to remember to do was to create a firewall rule to make sure that the minions could be accessed in that port from outside. And you just do that. You don't have to do specific minions. You just, there's labels used for all of that. And so if I go to the service, so this is running, is Jenkins running, okay? And this is the external IP that Google is providing for that container. And I have 2 slaves, as you saw before in the replication controller. Well, I just resize it to 2 again. But if I resize it to 3, well, this is running with 2 really small nodes, so may take a little bit to come up. Oh, well, not so much. Now I have 3 slaves. If I go in and say 4 slaves, then it should pick it up in a moment. There it is. And with that, you also have complete access to the minions or the nodes if you want. I can SSH into one of the minions, and you can use all the Docker stuff. You can see what's running. I can see, well, this is what I mentioned. There's a lot of services running by default, but I have a slave here, and I think that's it in this container. So there's 2 and 2, 2 in one node, 2 in another node. And this is the other node. So there should be 1, 2. So you can do, this is useful if you need to debug something. Although now, in the latest versions, Kubernetes also provides log services. You can get the logs directly from the command line and through the master. You don't have to log into the box. But if you want to look at the Jenkins, the container logs, then you can do that. And just the last thing, probably, if I resize it back to 2, it also depends on how your application is going to handle that sort of stuff, right? It's not just using containers as magic. Your application also has to handle what if these things disappear at some point, right? If I was connecting to them and for some reason they don't die cleanly, I'm going to go crazy, or I'm going to gracefully fail, or what's going to happen. And I guess with all that, there's like 5 minutes for questions if you want to ask something. The slides, I'm going to put them up in SlideShare. The code is on GitHub. So that's gonna be all for me. Thank you. Well, questions? No questions? Yes?
What about data migration or upgrading the database?
Well, data storage is one of the main, let's say, things to do in container world. With Kubernetes, right now is the Google disk is the best thing I've seen. But then I'm sure there's going to be, you will have to use some other techniques or technologies or services to do the data. If you store the data on S3 or on Google storage, then that's solved. But if you need a physical, a disk, then that's something that you need to solve in some other way. So if you mount things, when you have only one Docker host, that's what I mean when you get solutions to existing problems, but you get new interesting problems. When you have one Docker host, you can just mount everything on the host and mount it on the containers from the host. But when you have two Docker hosts, and one container dies and gets restarted in another cluster, in another region, in another place, how do you migrate that? So that's something that needs a lot of thinking.
But could it be done with data containers and I don't know?
So the question is, could it be done with data containers? Well, the data containers, so when in a pod, you are guaranteed that all the containers in that pod are going to run in the same node. So you could do the same thing you would do with one Docker host, whatever that is. Because, so how are you going to mount, how are you going to get the data if that container dies or that pod dies into a new node when the pod gets restarted there? Kubernetes is going to handle that. If it's going to know, if you ask me to have 10 containers running in the replication controller and one of them dies, I'm going to start another one. So how do you move the data if something is still to be done? More questions? Yes? Can you specify your constraints on data location? You can specify some constraints. This has been added just recently, I think. You can set like CPU or memory, and you can use labels. So you can use labels on minions, on nodes. I keep using minions. And you can use specify constraints based on those labels. So you could label your nodes as these nodes are in this place, or these nodes are in this other place. And you could say, I want this pod to run on minions in this place. So for example, pre-production, production, development, you could say, I want this to run in nodes that are pre-production. So you could do something. It's not just, let's say, final solution, grade type solution. More questions? Yes? Again? Yeah, 1.0? 1.0 of Kubernetes? Yeah, Kubernetes is, I think there's several versions released every week. The 1.0 was supposed to happen in a month or so. That's what I keep hearing from people, yeah. I don't know what's going to be because it just changes so fast that I'm telling you, I wrote an article for InfoQ, and the examples a month later wouldn't work because stuff changed. Yeah. Any other questions? No? Well, okay. I'm going to be around. If you want to talk in French with me, that's fine. Well, practice. Merci beaucoup. À bientôt.